Hey, welcome back. This time we're going to talk about hashing functions. We have modulo hashing, direct modular division, and then there's base 10 mid-square hashing, identifying the numbers via binary and selecting the portion to be divided. Base 2 mid-square hashing, a similar fashion but with a log2 function instead of using the direct log10. Multi-string hashing, using multiplier. A position value is updated by having it multiplied and being added onto the number of each character in the numbers word until the end position is modded by n. And Adler 32 hashing, splitting the characters of the numbers up and then changing them by adding the other two ends onto them through the length of the numbers word and then returning to the ideal number to be modded. 15 is like the number of buckets, and R is the number depending on the algorithm. Modulo hashing is basically direct mod. We have base 10 mid-square hashing here. We start with the R, making it int of mass CO, where it basically rounds up. Position is key to the second power. Make that an int. String position is basically an integer of the position as a integer of it as a string. The R digit is basically right digit value, ceiling of the R subtracted from the length of the string position, which is then split in half. String position becomes the front to the value where the R digit is from the back. In left digit is R subtracted from the length of a string position. String position now becomes where L digit is up until the length of a string position. And then it returns the integer of string position, and then it mods that by n. Alright, we got base 2, initiating R with dividing it by log of 2, with that of the mod log of n. Position is once again key squared. Okay, integer using a binary string this time. R digit is basically single of R. A similar thing for string position and all that. Decinum is going to be the integer of SPOS and then base 2. Decinum is modded by 15. Public int, then we have public int multi-string hashing. We start with the number, then it's the multiplier is 3. For each character in the length of key, car character becomes that specific character. Then we have the numcar, which brings that to an int, and then number is going to equal itself times the multiplier, and then add the num of character, and then you return number modded by n. And then we have Alder mod, which is that big number 65521. We have the A and B. And for each loop on keys length with C, the character is now the number at C minus 1. A equals the mod of the sum itself plus the character amidst all the mid. B equals the mod of the sum of itself plus A amidst all the mod. And then it returns B bit shifted 16 logical with A being modded by n. Alright. And now we have this. We're going to compare 7, 18, and 45. And for the string stuff, we put it as of course, a string. Alright, here we go. Alright, we got ourselves 7 mod 15 would be 7, 18 mod 15 would be 3, 45 mod 50 is even, so that would be 0. Then we have the mid-square hashing, 7 outputs 4, 18 and 45, each output 2. For base 2 mid-square hashing, 7 and 18, each output 8, 45 outputs 14. And for the strings, we have 7, 2, for multiplicative string hashing, then it's 18 for 14, 45 for 11, and then Alder 32, it's 7, that output 6, and 1845 each output 5. This was a pretty fun project that I made for class, and it was one of the more important lessons. I hope this was helpful to you. Subscribe if you want.